Okay, so today we are continuing from where we left off yesterday. The first thing we're going to talk about are complex conjugates. So do you guys remember what the conjugates were with the radicals? Like if I had 1 plus the square root of 5. What's the conjugate for that? 1 minus square root 5. Well, it's the same idea with complex numbers. A plus bi and a minus bi are conjugates of each other. And so if we multiply our conjugates together, what happened when we had the radicals and we multiplied them? Why did we multiply by the conjugate with the radicals? It made the radical go away, right? It became a rational number. Okay. Well, a similar thing's going to happen here. If I multiply my conjugates together, the imaginary part's going to go away. And so the product of the conjugates is always real. And I'll just do a quick little example just to show you that that works. So for example, if I have 2 plus 4i times its conjugate, 2 minus 4i. Okay, if I multiply it together, 2 times 2 gives me 4. 2 times negative 4i gives me negative 8i. 4i times 2 gives me positive 8i. And then 4i times negative 4i is negative 16i squared. So now you can see how, because you've got that sum and difference pattern, your middle terms drop out. And what happens with that negative 16i squared? It becomes a positive because that's like negative 16 times negative 1, right? So we end up with 4 plus 16, and so it equals 20. And 20 is a real number. And so that's always going to happen when we multiply the conjugates together. We're always going to end up with a real number. And so we need that for when we divide with complex numbers. I am not kidding you. Isn't this exciting? Fun as always. Exactly. All right. So all I have to do to get this quotient in standard form is multiply the top and bottom by the conjugate of the denominator. Okay, so I'll write that down. We are going to multiply. I don't know what's wrong with my screen. We're going to multiply the top and the bottom by the conjugate of the denominator. All right, so I am going to take my problem here, 7 plus 5i over 1 minus 4i. So what is the conjugate of the denominator?
1 plus 4i.
1 plus 4i. So I'm going to do 1 plus 4i on the top and the bottom. And I'm going to multiply them. So 7 times 1 gives me 7. 7 times 4i gives me 28i. 5i times 1 gives me 5i. And then 5i times 4i is 20i squared.
So you got rid of the bottom and then you just kind of distributed?
I've only taken care of the top right now. I haven't done the bottom yet. But yes, I'm just distributing. I'm just doing FOIL or however you want to call it. Okay? I just FOILed the top. Now I'm going to do the same thing to the bottom. Okay? So 1 times 1 is 1. 1 times 4i is a positive 4i. Negative 4i times 1 is a negative 4i. And negative 4i times positive 4i is negative 16i squared. Okay, so I have 7 plus, I'll go ahead and put my 28 and 5 together, 33i. And then my 20i squared is negative 20. And then over here, the 4 i's cancel out, so I've got 1. And then my negative 16i squared becomes a positive 16. So yes, I have 17 on the bottom of the fraction. So see how there's no more imaginary number on the bottom? Okay. All right, and then on top, 7 minus 20 gives me negative 13, and then I have plus 33i. Now, if I want to get it totally into standard form, then I need to separate the real from the imaginary. So basically, all you have to do at that point is just divide both of them by 17. So it would equal negative 13 over 17 plus 33 over 17i. And that would,
Like, is there gonna be?
if it asks for it in standard form, you should take that last step and separate them.
On a test, can we leave it?
No, not if I say
So what's
standard
the
form.
other form called?
The other form is just a transitional form. It doesn't have a name. It's just you're on your way there. But yeah, if I specifically say standard form, I want you to follow instructions and put it in standard form. Okay? It's only one more step. It's not going to kill you guys. All right, so let's have you guys try this one on whiteboard, okay? If you want to do it in your notes, you can, but I still want to at least see the answers on whiteboards, okay? So I know you're doing it. All right, I think we all ended up there eventually. Are you guys comfortable with this? Yeah? Okay. All right, then, let's move on. All right, the complex plane. Guess what? This is easier than you think. It's not that bad.
You know, actually,
It really is easier than you think. So instead of having an x and a y axis, I have a real and imaginary axis. So we just take the real part of the number, and that tells us how to go horizontally. And we take the imaginary part, and that tells us how to go vertically. So basically, everything along here is 1 unit, and these are all my I units going up and down. So if I want to go to 3 minus 2i, I go to a positive 3 in the real axis, and then it's a negative 2i, so I go down, and there it is. It's just a point, 3 minus 2i. And that's all there is to it. I'm just going from... Yeah, it's so easy, isn't it? So I'm just going, this tells me how to go horizontally, this tells me how to go vertically. So 3, negative 2. What am I going to do on B? Negative 2 of 4, exactly. So for the next one, we go backwards 2, up 4, and there is negative 2 plus 4i.
it's like an imaginary worksheet. No, seriously, make an LS or something.
An imaginary worksheet. Okay. All right, we'll see about that. All right, so C is just 3i. So do I have a real part? No. So am I going to move left or right? No, I'm just going to go up to 3i. 1, 2, 3i right there. It is the imaginary intercept. All right, and then the last one, I've got negative 4 minus 3i. So now I'm going backwards 4. 1, 2, 3, 4, and down 3. 1, 2, 3.
Do anything with them? You just graph them?
We're just graphing them. We are gonna do something with them in a second. All right. So, how about if you guys graph that one for me on your whiteboard, okay? Okay, so we just had to go in the positive 4 direction, 1, 2, 3, 4, and down 1. Looked like you guys had that. All right, how about that one? Negative 3 minus 4i. All right, so for that one, you guys we went backwards 3, 1, 2, 3, and down. It's right in the way there. All right, so now that you got that down. All right, so now here's how we're going to use it. We're going to use that graph to figure out the absolute value of a complex number. All that the absolute value is the distance. Okay, so think about just regular real numbers. When I take the absolute value of like -5, where did that come from? Do you guys remember what the definition of absolute value is? Nobody remembers. It's the distance from 0, isn't it? Yeah, when we're talking real numbers, it's just the distance from 0 on a number line. Well, essentially, it's the same thing with complex numbers. It's the distance from 0. It's just now it's the distance from 0, 0. Okay, so it's the distance from the origin.
So then, like, how do you count it? Do you have to count it? Or, like, because you said it's a distance from the origin.
From the points.
And the point on the graph.
Oh.
Okay, so my origin is 0 plus 0i, right? I have 0 real and 0 imaginary. And my graph, okay, so let's look at just this first one. We've got the absolute value of -4 plus 3i. Okay, so if I plot that point on my graph, I'm going in the -4 direction horizontally, right? And then up 3. So that's the point -4 plus 3i. Okay? The absolute value, except for I counted wrong, didn't I?
Yeah.
I just realized that. 1, 2, 3, 4. There we go. 1, 2, 3. That is the point right there. Okay, so -4 plus 3i. All right, so I want to find the length of this right here.
So it's like this.
So do you have to find the slope?
It's the Pythagorean theorem, yeah. Because I can make this into a triangle, can't I? And this side's 3, and this side's 4. So if I call that x, doesn't x squared equal 3 squared plus 4 squared? Yeah, so the absolute value is just the square root of 3 squared plus 4 squared, which is 9 plus 16, or 25. And so the absolute value of -4 plus 3i is 5.
Where'd you get 25?
From 3 squared plus 4 squared.
3 squared is 9, plus 4 squared is 16, equals 25. Okay, and if I take the absolute value of -3i, let's do that in green. All right, so I go to -3i, it's right here. Do I need to make a triangle?
No.
No, I can tell what the distance is right here. How far is it? It's 3, so it equals 3.
So on like a problem, it's gonna be like that. It's gonna be like 2 of them.
On what's your question?
On like homework.
On homework problems?
Yeah, is it gonna give 2, or is it just gonna have like the 4i one?
It could be either way. You'll have both types. So here's a chance for you to practice. Let's take the absolute value of 4 minus I on your whiteboard. All right, so when you plotted the point 4, negative I, you should have got a triangle with sides of 4 and 1, right? So the square root of 4 squared plus 1 squared, which is the square root of 17. All right, let's do one more because I feel like you guys aren't totally comfortable with this. How about this one? Okay, so if we plot negative 3 minus 4i, that means I'm going backwards 3 in the horizontal direction. I'm going down 4, and so that's the point right there, okay? So here's my triangle right there. So this is 4, this is 3. So it's the square root of 3 squared plus 4 squared, and that comes out to 5 again, okay? All right, thank you.